All right, so we're talking about section 4.1 today, and 4.1 is about distance from velocity. So, in general, right, we might know this formula, depending on whether you've had some physics or not. Distance equals rate times time. So, kind of in the simplest case, suppose my velocity is a constant number. Suppose it's 30 miles per hour, and I've gone for 2 hours. So 30 miles per hour over 2 hours, how far have you traveled? The answer would be 30 times 2 or 60. So just as a quick example then, we could plot that, right, of our velocity function. If it's a constant 30 and that's over 2 hours, this is not to scale, so this is 1 hour, this is 2 hours, and 30 would be our miles per hour, right, just to be clear. Yeah, so um, then over 2 hours we have gone 60 miles, right? So if our velocity is constant, then it's pretty simple to figure out how far you've traveled over a certain time. You just take distance equals rate times time. Good. So let's make it a little more complicated. So let's suppose now that I only travel at a rate of 30 miles an hour for the first hour, but then I drop down to 20 miles an hour for the next hour. So these vertical lines are not part of the graph, right? I'm just drawing them so you can see where the lines go here. Then for the last hour, so I'm going 30, I drop by 20, or I drop to 20, and then I drop to 10 miles per hour. Okay, good. So then how far have I traveled in the 3 hours? Well, on the graph here, you can see for the first hour, you've traveled 1 by 30, so that would be 30 altogether. And then here you have 1 by 20, so that would be a 20. And here you have 10. Good, which is 1 times 10. Good, so overall then you have 30 plus 20 plus 10, 50, 60 miles traveled. Good. Now, when we're talking about a velocity like this, a positive velocity, we're assuming, means that you're going in a single direction, right? You're not changing direction. So if we say our velocity is positive, we might say, well, positive velocity means you're moving to the right. I'm moving my arm, but you probably can't see me. I'm moving to the right, and then negative velocity would be moving to the left. And so you might also then have something that looks like this. I have a velocity function over time, and then I travel 30 for the first unit of time, but now over the next 2 units of time, suppose I jump to, I just lost you. I go to minus 10. Okay. And so now the question is what is the distance that I've gone? So distance traveled, for t0 to 1, it's still going to be 30 miles, right? But then from time 1 to time 3, I've gone 10 miles an hour, but in the opposite direction, right? So in terms of distance, I've still traveled 10 times 2 hours, so that would be 20 miles. So that's time 1 to time 3. Okay, and so overall then I've traveled 50 miles total. Okay, that's the distance that I've traveled. Okay, now where am I in terms of my position? In the first hour, I've moved 30 miles to the right. And so it's from time 0 to time 1, we've moved 30 miles to the right. But then from time 1 to time 3, we're moving in the opposite direction at 10 miles per hour. And so we've moved to the left by 20 units, then moved 20 units left. And so where are you in your position? You're at 10 miles to the right. Okay, so this is your ending position or your displacement. And so this is the difference between distance, and this computation here is displacement. Okay, so I think I'll stop there, and then we'll pick it up from there, and we're going to talk about again the difference between distance and displacement.